Welcome, students. We are going to go over the lesson from class, which is graphing radical equations. And we started with a sketch, and we said that we wanted to see what the parent graph of a square function looked like. And we picked x and y values. But we had to remember that the values that we pick for x have to be positive, because we can't have a negative number underneath the square root. So we started with 0, and we said, what is the square root of 0? So the y value is 0. We then picked a 1, and we said the square root of 1 is 1. We then did not pick a 2, because square root of 2 means the decimal. We picked 4, because the square root of 4 is 2. And then we picked 9, because the square root of 9 is a 3. And then we went ahead and we plotted the points. 1, 1, 4, 2, 9, 3. And then we sketched it. And then we looked at the characteristics of this curve, this point being 0, 0. And we said that there is no vertical asymptote, that there is no horizontal asymptote. Even though this may look like it's a horizontal asymptote, this is increasing, right? As x is getting bigger, the function is also getting more positive. So there is no horizontal asymptote. It's constantly going up. Domain. Well, we looked at the x values and we said, well, when x is 0, the function is 0. When x is 2, the function is here. When x is 4, the function is 2. When x is 6. But when you look at the negative values, when x is negative 2, there is no function. When x is negative 6, there is no function. So the function only exists when x is greater than or equal to 0. We can also write this in interval notation and say from 0, and we're including 0, that's why I put it in bracket, x has to be 0 or greater than 0. So either one of those will be appropriate for the answer for the domain. The y values, well, we have the function has a y value of 1, see? It can also have a y value of 2, a y value of 4. It'll eventually be 4, right? Because remember, this is increasing. So it can be any positive value, but y can't be negative. The function is not defined for negative values. Okay, all x's, all positive x's give you a positive y. You never get a negative y. So the range, the lowest y value that you can have is 0, or this value. So the y has to be 0 or greater than 0. Another way of writing this in interval notation is saying starting from 0 all the way to positive infinity. X-intercept happens at the origin. Y-intercept happens at the origin. And behavior. As x gets bigger or more positive, the function gets even more positive. See? The function is increasing. As x becomes more positive, the function is going up. It's becoming more positive. So we would say this. As x goes to negative infinity, actually the function doesn't exist there. Increasing. Remember when we did intervals of increase? We talked about a little ant that, right, had 4 legs, antenna, and a little tail. And this little ant starts walking on the function. And is the ant going up or down? Well, since the function is climbing, the little ant is going to climb. So this is an interval of increase, and it starts at 0, right? Starts at 0. And as x gets bigger and bigger, the little ant is still climbing, so it's positive infinity. Remember, for intervals of increase, we only use parentheses. How about decrease? Well, the little ant's going to climb forever. It's never going to decrease. So we say does not exist. Okay? We have another radical function that we need to learn, which is the cube root. And this one's the parent graph right here. And then for here we pick some values, because something we talked about in class is that when you're taking a cube root or any odd root, the inside or the radicand can be negative. Right, so I started with a -8, and the cube root of -8 is a -2. I picked a -1, and the cube root of a -1 is a -1. I picked 0, the cube root of 0 is 0. So I went ahead and I plotted these points. And what does the function look like? Oh, this is hard. Must go through the points. Okay, here we go. I did the best I could with my digital pen. I think I'm getting more used to it. All right, and this is what the cube root function looks like. And you might think that we have a horizontal asymptote, but in reality, this is slowly going up and it is slowly going down. So there are no vertical asymptotes and there are no horizontal asymptotes. What about the main? Well, let's look at your x values. When x is 2, the function exists. When x is 6, the function exists. When x is -4, the function exists. So the function exists whether x is positive or negative. So the domain is from -infinity to +infinity. Okay. How about the range? Well, the function can have a y value of 1, can have a y value of 2, can have a y value of 3, but you're saying where? Remember the function is increasing? It'll eventually have a y value of 3, and it'll increase and have a y value of 4. Same thing down here. It'll keep on decreasing and it'll eventually have a y value of -5. All y values are possible for this function because it's continually increasing this way and decreasing towards the left. So for the range, we say y can be any number between -infinity and +infinity. For the x-intercept, we have the origin. For the y-intercept, we have the origin and behavior. As x becomes bigger, the function becomes more positive. As x gets bigger, the function becomes more positive or approaches +infinity. As x becomes more negative, the function's becoming more negative. See? So we say it is approaching -infinity. How about intervals of increase? Well, let's sketch a little ant. And remember, the little ant starts all the way on the left. There's the tail. The little ant's going to start walking, and what's the little ant doing? It's increasing. It's climbing. You see that? And it's going to climb forever. So the interval of increase will start from -infinity all the way to +infinity, and there is no interval of decrease. Horizontal translation. For all intensive purposes in our class, b is going to be equal to 1. We're now going to vary b. We're going to vary the a in front, the h, and the k. If it's positive or if it's negative. If it's positive, the square root of x will do this. And if it's negative, the square root of x will do this. It'll go under. Okay? If it says -h, it's going to the right. And if it says +h, it's going to the left. If it says +k, it's going up. And if it says -k, it's going down. Okay? For the cube root of x, right? If the cube root of x is positive, it's going to do this. And if the cube root of x is negative, Whoa, I put the 3 here and the x here. 3 here and the x there. Instead of starting here at the bottom and going up, it's going to start at the top and it's going to go down. Okay? Then everything else is going to stay the same. All right. What is this 2? Well, think about it. Does the 2 represent the number outside of the square root, the number inside the square root, or the number that's being added to the square root? It represents the h, and the h is your horizontal translation. And if it says minus the number, minus h, it's going to the right. So this is moving to the right 2 units. Okay? And it's the square root of x, positive at that. So let me go change the color. So it's moving to the right 2 units. So it used to be at 0, 0. Now it's moving to 2, 0. And what does the square root of x look like when it's positive? Swooshing up. So this one's swooshing up. See? Normally the square root of x does this, right? This is y equals the square root of x. But it has been shifted 2 units to the right. All right, the next one. Let me pick another color. Because I can. All right, this one says plus 3. Now stop and think. What does the 3 represent? Does the 3 represent the number outside, the number inside the square root, or the number that's being added to the square root? This represents the number inside, and the number inside moves you to the left or to the right. It's plus 3. So plus a number means you're going to the left. So we're going to the left 3 units. One, 2, 3. And this number is minus 3, 0. And it's the square root of x, right? What is the behavior of the square root of x? It does this. There you go. It's been shifted to the left 3 units. All right, this one. Now this one is the cube root of x, okay? Minus 2. Once again, this minus 2 represents the h because it's still inside the radical sign. And it's minus a number, so that means you're moving to the right 2 units. Right, same thing here was minus a number and we went to the right 2 units. But this one is the cube root of x. All right, let's first draw the scale, x and y. And let's move to the right 2 units. 1, 2, right here. Right, and this point would be 2, 0. And this is the cube root of x, and the cube root of x is that s-looking thing. And it's positive, so it's going to do this. Okay. All right, the next one. The next one is the cube root of x plus 3 inside the radical sign. Inside the radical sign, a plus a number means you're going to the left 3 units. And that's the only transformation. 1, 2, 3, right here. So minus 3, 0. And it's the cube root of x, and it's positive, so it's going to do this. There you go. We have sketched horizontal translations. Vertical translations. This is when you have plus k. And if you remember in the previous units, in the previous slide, if it's plus k, we go up, and if it's minus k, we go down. don't have to keep on switching color. All right, here I go. Plus 4 means we went up 4 units. 1, 2, 3, 4. This point is 0, 4. And it's the square root of x. So it's a little swoosh. Square root of x minus 1. That means we went down 1 unit. So this is 0, negative 1. And it's the square root of x. So that means it does this. Cube root of x plus 4. 1, 2, 3, 4. We're moving up, remember, because this is that plus k. It's outside of the square root. This is 0, 4. But this one is the cube root of x. Remember, the cube root of x is that s-looking thing? So it does this. Goes through the point, and it does that. This one is the cube root of x minus 1. So we drop 1, 0, negative 1. And same thing, this one is the cube root of x. So it's going to have that S shape behavior. Perfect. All right, reflections on the x-axis. All right, negative square root of x. Instead of going up this way, it's going to reflect and it's going to do this. Cube root of x, instead of starting here at the bottom, is going to start here. Oh, how do I erase this? Have to be careful. There we go. Remember these shapes. All right, how to calculate the x-intercept. If you're looking for x, y is 0. So assume this is your y. 0 equals the square root of x plus 1. All right, we want x. We have a square root. So what do we do when we have a square root? We square both sides. 0 equals x plus 1. Getting rid of the plus 1, we get x equals negative 1. How do we report the answer? Negative 1, 0. Next, since you want the x-intercept, y equals 0. That's your y. 0 equals the square root of x plus 16 minus 5. Now we have to solve this, but we got to get rid of the minus 5 first. So we got to say plus 5, plus 5. This goes away. And now we have 5 equals the square root of x plus 16. And since we got a square root, we got to square both sides. This is 25 equals x plus 16. We're going to subtract 16 from both sides. And we have x equals 4 and 5 is 9. The answer is going to be 9, 0. That's the x-intercept. Let's do it again. We want the x-intercept, so we're going to set the function equal to 0. So 0 equals the cube root of x plus 1. Since we have a cube root this time, what we're going to do is we're going to cube both sides. 0 cubed is 0. And this is the same thing as before, only the inside survives, x plus 1. Since we're solving for x, we got to get rid of the plus 1. We got x equals negative 1. The answer is going to be reported as negative 1, 0. As an x-intercept, it is a coordinate point. Let's do it again. Let's solve for the x, which means our function is going to be equal to 0. Cube root of x plus 8 minus 3. We got to get rid of the minus 3, so we have to add 3 to both sides. We have 3 equals the cube root of x plus 8. And since we have a cube root, we got to cube both sides. And we got 27 equals x plus 8. Remember, only the inside survives. Minus 8, minus 8. And this gives us 19. So the answer is 19, 0. Right? That went well. Let's do the y-intercept now. For the y-intercept, since we want the y, that means x equals 0. So wherever we see an x, we're going to put 0. And we're going to turn this into a y. Y equals 0 plus 1. And then you would just type this into the calculator. But let's use our mental calculators. What's 0 plus 1? 1. What's the square root of 1? 1. Y equals 1. How do we report the answer? 0, comma 1. Let's do it again. Since we want the y-intercept, that means the x is 0. Y equals the square root of 0 plus 16 minus 5. And then all of this, the way you see it, you type it in your calculator. All right, I'm going to use my mental calculator. 0 plus 16, 16. Square root of 16, 4. 4 minus 5, negative 1. The answer is 0, comma, negative 1. Plug it in a calculator if you can't follow the mental calculator. All right, let's do it again. Y-intercept, that means x is 0. This is y. Cube root of 0 plus 1. All right, calculator. 0 plus 1, 1. Cube root of 1, 1. 0, comma 1. The last problem, let's find the y-intercept. Y equals the cube root of 0 plus 8 minus 3. We got to get rid of the minus 3. Oh, what am I doing? Never mind. It's all numbers, so we just put it in the calculator. All right, mental calculator. 0 plus 8, 8. Cube root of 8, 2. 2 minus 3, negative 1. So the answer is 0, negative 1. All right, that went well. Domain and range. All right, domain for cube roots. Range for cube roots is, so this is a square root, a cube root. What is the domain? All reals. What is the range? All reals. There's nothing to calculate as a cube root. Now, if you've got a square root, we cannot allow the radican. We can't allow the inside of the radical sign to ever be negative. So for the domain, you have to write an inequality. You have to say the inside of the radical has to be greater than or equal to 0. And in here, we solve for x. So we have to subtract 1 from both sides. And this cancels. We have x is greater than or equal to negative 1. Or you can also write it as negative 1, comma, to infinity. That means it's got to be greater than negative 1. This one is fine. Range. Y has to be greater than or equal to k. So which is the k value? Remember, this is plus k. And since there's nothing here, that means it's plus 0. That's our k. So the range is y has to be greater than or equal to 0. Let's do it again. This is a square root, and we want the domain. For the domain, the inside of the radical. This minus 5 is not inside the radical. Only the x plus 16. We have to ensure that it is positive. So we have to write an inequality saying that this must be greater than or equal to 0. And then we solve for x. In this case, all we have to do is subtract 16. We get that x has to be greater than negative 16. Those are the only values of x that are allowed. That's the domain. For the range, y has to be greater than or equal than the k value. Well, which one is the k value? This one right here, the negative 5. So y has to be greater than or equal to negative 5. I don't know what happened here. It erased. Because it's a cube root, the domain and the range is all reals.